So, in case we don't have school on Wednesday, I'm figured to do some of these examples for you. So, we're going to separate the variables. Now, what that means is you're going to have a differential equation that's going to have uh, your derivative, your slope formula, and then what you're going to do is you're going to try to break this up so you have a function in terms of x times a function in terms of y, and sometimes you'll already have that. In fact, most of these you'll already have that. And then what the job is we're going to separate the variables. You want to get the y's with the dy's and the x's with the dx's. So I'm looking at number 1 here. So I see dy over dx equals 2 times x times 1 over y. So you see how I wrote this as I thought of this as f of x times g of y. So here's the x function, here's the y function. So as is, that's hard to integrate. So what we're going to do is separate the y's with the dy's and get the x's with the dx's. So I'm going to pretend this is a fraction for a minute. And what I'm going to do is I'm going to multiply both sides of this equation by y, and that will give me y times dy equals 2x times dx. So do you see what I've done here? Let's see, can I get a pointer here on this screen? I guess. See, I've got the y dy. I moved that. So what do I want to do? I guess I want a pen, huh? I guess I move that dx with the x, and I move the y with the dy, and that's what you usually try to do when you're separating variables. And these are the hardest differential equations we'll see in this course. So then what we're going to do is we're going to integrate both sides of this expression. And this one's not too bad to integrate. Well, I know y, I'm going to add 1 and then divide by what I added. And then, now there is a plus c over here, but we'll talk about that in a minute. So on this side, I'm going to get, I'm going to make that 2 divided by 2, so that just becomes x squared plus c. Now, isn't this c that's over here and this c over here, they might not be the same number, but they're still just a constant. And if I subtract this c from this c, it won't necessarily be 0. It could be, but it doesn't mean it has to be. So we're still going to have some constant over here, whatever it is. So we're just going to write the plus c in the one side with the x, so we don't have to deal with that. And then what we're going to do is we're going to solve this for y. I mean, a lot of times in the AP test, this will get you full credit. It depends on the question and what they're looking for. Remember, it's a situation where you don't want to do more work than you need to because you might make a mistake. But for this worksheet, we'll solve them for y. So this is going to be 2 times x squared plus 2 times c is some constant still. You know, and as I'm looking at this question, I think we're just gonna leave it at this point, because we could do this, right? If I took the square root of both sides, I could get the negative square root of 2x squared plus c. I could also get the positive square root of 2x squared plus c. And at this point, they don't tell us anything else, so let's leave it alone. Okay? So that's my answer for the first one. So then, let's see, because I'm doing this on the smart board, it doesn't stop as nicely. Let's do this next one. So what I'm seeing for number 2 is I'm not seeing any x's, so I'm going to separate the variables. So really there's a 1 here though, right? So it's y squared times 1. So if I divide both sides by y squared and multiply both sides by dx, isn't that what I'm given? So I'm going to integrate, let's see. I'm going to integrate 1 over y squared times dy, and that equals the integral of 1 times dx. Well, this is going to become y to the negative 2. Now I'm going to add 1, which will give me y to the negative 1, and then I can divide by negative 1, so I've got a negative out in front, equals x plus c. Now, if they want to solve this for y, I'm going to think of this as negative 1 over y equals x plus some constant. And if I just treat this as a proportion, do my cross products, that's going to give me y equals, well, let's see, I'll go slow. So y, I'm going to get negative 1 equals y times x plus c. So then I'm going to divide by the x plus c, which would give me, I'll write it over here. So y equals -1 over x plus c. And at this point, till they tell me some more values, an initial value, I'm done. Okay, now let's do the next one. So here I'm seeing a dy over dx equals 4y. So if I divide both sides by y, that'll give me 4 times dx. So now if I integrate 1 over y dy, and I'm going to integrate 4 times dx, this is going to give me the natural log of y equals 4x plus c. And then I could leave it here. It's really nice to have it in terms of y. So if I exponentiate both sides, so if you treat both of those as exponents, the y, the e, and the ln cancel out nicely. So y equals e to the 4x plus c. Now to clean this up anymore, and if you go start looking at the problems in our textbook, when I multiply, what you got to remember here is if I have a to the x times a to the y, isn't that the same thing as a to the x plus y, where you're adding the exponents? I can go backwards here, and that's what's happening here. I can treat this as e to the 4x times e to the c, and e to the c is just e to some constant, it's just a constant. So often what we'll write as this is a times e to the 4x. Okay, this will come into play a lot in the AP test. Okay. So that's that, question number 4. Okay, for question number 5, here they told me it's the same as number 4, except instead of telling me that 4 times y, it's k times y. And this is going to be the shortcut that we're going to see often. Maybe I won't go too much into that today. Yeah, I messed that up. So I'm going to put the y on the bottom here, the dx over here. So if I find the integral of 1 over y, the antiderivative of 1 over y dy, that equals the integral of some constant times dx. Well, that's going to be the natural log of y, and we should use absolute values, and times k times x plus c. Then we're going to do that exponentiation trick again. That's e raised to the k times x plus c, and if you remember that this is e to the kx times e to the c, and e to the c is just some constant. That's going to be the general solution, e to the k, a times e to the kx. So what I'd like you to jog in your memory, if you ever are given this kind of differential equation, you can just jump to that relationship. It's probably going to take you some practice to get there, but that's what we do. Okay, so that's that question. Let's see. I just realized I'm missing some problems here. Oh, that's okay. Let's drag this screen back over here, and I'll do number 3 and number 6. I'm not going in order here. Okay, so I'm going to solve that, separate the variables. I'm going to say 3y squared dy equals x plus sine x times dx. And if I integrate both sides, I'm going to get y to the third equals, now this other side, what you can think about is I've got the integral of x dx plus the integral of sine x dx. Well, that's pretty easy to integrate. 1/2 x squared plus some constant minus the cosine of x plus some constant equals y to the third, and then I'm just going to take the cube root of both sides of this equation. So 1/2 x squared minus the cosine x plus c. And the c is underneath the radical too here. Okay, so that's number 3. And I'm going to do number 6. So this I see an x and a y. So I'm going to divide both sides of this equation by y. I'm going to multiply both sides of this equation by dx. So the antiderivative of that, the antiderivative of that becomes natural log of y equals 1/2 x squared plus c. So we're going to exponentiate it again. So that'll become just y because the l and the e cancels out. E to the 1/2 x squared plus c. And remember, e to the c is 0, so we could write this as y equals ae to the 1/2 x squared. You know, I encourage you folks to check your work with Wolfram Alpha. I mean, they don't give you really nice, neat answers, and it'll help you to verify that you're doing some math right and make you work backwards from what they have to what you probably have. So that's worth doing. Okay. Now we're going to go to problem number 7. And that is blurry there, but on my paper, I see that this is e to the u plus 2t. So, and then since they told me that the u is on top, that's the y, and the t on the bottom, that's the x, just so you can make that connection. So, how do we separate? Remember, we're trying to get f of x times g of y. In this case, it's going to be f of t times g of u, or something like that. So, if we treat this as e to the u times e to the 2t, that'll let me, I've got the product going on, that'll let me get the u's over with the du's, so e to the u equals e to the 2t times dt, and this is, now we're going to do the antiderivative, so this is going to become e to the negative u times du. So the antiderivative of e to the anything is e to the anything, but then you got to remember the derivative. So that's going to give me, right, negative e to the negative u, I believe. Let me take a look at my work. Right. Equals 1/2 e to the 2t plus some constant, because remember, if we take the derivative of e to the 2t, up here they didn't have any 2 kicking around, so I had to have the 1/2. Now if we want to solve this for u, which is our y, I guess I'm going to divide both sides by -1. So that'll give me e to the negative u equals negative 1/2 e to the 2t plus c. Remember, c could be negative, that doesn't matter. Now, if I take the natural log of both sides, that gives me negative u equals the natural log. I'm going to use absolute value signs. It's always safe to do that. 2t plus some constant. And then I'm going to divide by the negative, so I get negative ln. And they might do something fancy with, the exponents, but they might not. So that certainly works. That certainly is one answer. Okay. So then let's look at number 8. All right, so we got to break that up into 2 things that are being multiplied. I'm seeing 2 terms with t's. So why don't we try some factoring with grouping with this? Guys haven't looked at that since, well, I guess you did a little bit of it in pre-calc, but boy, since algebra 2. So let's see, if I'm going to group this as 1 minus x plus t minus tx, and if I think of this as 1 minus x plus, and factor out a t, then I'm seeing I've got a 1 minus x and a 1 minus x. Let's factor that out. That's where the factoring by grouping comes in. So that's 1 plus t. There we go. Now I've got an x function and a t function. That equals dx over dt. So now I'm going to get the x's with the dx's and the dt with the t. So that's going to be dx over 1 minus x equals 1 plus t times dt. So now if I integrate this, let's see, can I drag that whole thing up? Let's see. So now I'm going to integrate this side, find the antiderivative. So the natural log, I mean, you could do a u substitution over here. Let's convince you. So 1 minus x, so du equals negative 1 times dx. So I could think of this as negative integral, because I got to bring the negative over here with the du, right? Negative integral 1 over u du, well, that's going to be the natural log. So negative natural log of, let's see, what did we say was the, so 1 minus x equals, so now on this side, I'm going to get t, I'm going to get plus 1/2 t squared plus some constant. Okay, so let's move some stuff here. See if it'll let me do that. Okay, so then I'm going to take, let's see, I guess I'm going to divide by the negatives, get rid of that. So natural log of 1 minus x equals negative t minus 1/2 t squared plus some constant. Now I'm going to exponentiate everything, right? Treat that like a base. Treat that like an exponent. Treat that like an exponent. That leaves me 1 minus x equals e to the negative t minus 1/2 t squared plus c. And then I'm going to add, I guess I'm going to bring the x over here, bring that mess over to the other side. So that'll leave me 1 minus e to the negative t minus 1/2 t squared plus c equals x. And then we could probably make e to the c a. So 1 minus a times e to the negative t minus 1/2 t squared. So that's as good as we can get with that problem. Alrighty. So I'm going to stop this and make a new video for the next part.